All right, we are working with sum and difference formulas today. Again, these provide a way for us to find exact values of trig functions that aren't on the unit circle by themselves. So we saw this example earlier. Find the exact value of sine of 15 degrees. Well, at 15 degrees I don't see in my unit circle. Of course we know where it is, right here, right halfway, but it's not on there. So these sum and difference formulas are going to provide a tool for us. So couldn't I rewrite the sine of 15 this way? Wouldn't it be the same as sine of 15 degrees would be the same as the sine of 45 degrees minus 30 degrees? Now if you look at your unit circle, by the way, there's other combinations we could use. I like to keep it as simple as I can. 45 minus 30, well that's 15. How did I know to do 45 and 30? Well, they're on my unit circle. So the key is we use the sum and difference formulas are to find combinations of two angles, either adding or subtracting them, that gives us the angle that we want. 45 minus 30 is 15. Now I could have done 150 minus 135, 240 minus 225, 315 minus 300. I mean, there's a bunch of combinations. I like to just keep it pretty simple. So now let's see how to apply this. So I've highlighted, I put the formula from your trig sheet right above the unit circle here, and I've highlighted the yellow one, I highlighted the subtraction, the difference here, because there's not a way we're going to add two angles on here to make 15 degrees. So subtraction seemed like the way to go. So using this formula, let's go ahead and list it out. So sine of 45 minus 30. So in this case, notice my alpha, my first angle is going to be 45. My beta is going to be 30. So let's list this out and see what it's going to look like. So this is going to be sine of 45 degrees times cosine of 30 degrees minus cosine, and then they just switch, cosine of 45 degrees times sine of 30 degrees. Okay, and that's just my formula. Now where do I get these values? I go right to the unit circle. So sine 45, you look here, of course it's root 2 over 2. So root 2 over 2, cosine of 30 right here, and of course it's my x value, so root 3 over 2 minus cosine 45, of course, root 2 over 2, and sine 30, you look at your unit circle, is going to be 1/2. Now let's just simplify this. Root 2 over root 3 is square root of 6. Root 2 times 1, of course just root 2. On our denominators we've got 2 times 2 is 4, 2 times 2 is 4. So that is all over 4. Now, I would encourage you to go ahead in your calculator. Just do it real quick. Plug in, make sure you're in degree mode. Plug in sine of 15 degrees. In fact, let's just do it. Let me bring it up here on my screen. So let me make sure I'm in the right mode. So let me go to degree mode. So if we do sine of 15 degrees, now it's going to be some big ugly decimal, okay? All I want to do is verify, and I'll just do this once to kind of show you how you can check stuff. Is this weird looking radical answer we just found the same as 0.2588 blah blah blah? So let's go ahead and plug it in. So I'm going to go ahead and just put it a fraction so it'll kind of look like what we're plugging in. So square root of 6 minus square root of 2, that is my numerator up there, right? All over 4, and lo and behold, we get the same thing. So that's nice to be able to check yourself. Okay, so the key, whatever they throw at us when we're using these, you want to find two angles from our unit circle, because we know those exact values, we can find them, that add or subtract in such a way to give us the angle that they want. Then it's just plug and play.